Thank you all. We've heard heaps of fantastic science about soil, but I'd just love to hear from each of you what's sort of one thing that we can do going home today to improve our soil or protect it or enhance it in some way.
Only one thing. Okay. Avoid digging where possible, because soil is used to being nudged like a bandicoot or an echidna, but it's never been dug. Soil hasn't evolved to be dug 30 centimetres down over 1,000 acres, or even in a single garden bed. So avoid digging where possible.
I guess if I was to give you one piece of advice is protect yourself from erosion, whether it be a cover cropping or using mulches and composts.
I was going to say maintain cover, but you just said that. So I would, thinking on the fly, I think really thinking about what impact your actions may have on the life in the soil. So just use soil health. People often say, I'm going to measure soil health. It's hard to actually know what the right number is, right? But I think of soil health as a lens through which you view your management. So if you think, what will this do to the health of my soil? That's the approach I'd take.
I'm going to go with a variety of plants. Try where you can to put a variety of plants in, because then you'll get the interactions below ground, and diversity above ground reflects diversity below ground. So, and that's multiple benefits from that.
No, excellent. Oh, yeah, sorry, we've got another question on.
Yep, sorry, Ed. I'm not sure who wants to answer this, but what value do you see in the current soil biology testing that's being done in the wider community at the moment?
Well, I think the way we've got to look at it is that as we've advanced significantly in technology, we can actually now get a pretty good idea of what's present. I mean, the old way of testing was really to plate things out onto media and see what we can grow. And, we're probably down to around 2 to 5%. But, the current crop now with, new age of sequencing, the use of PCR and that type of thing, you can actually get a much better idea of what's present in the soil. So I think it's a moving feast. I think it's certainly something that's advanced a lot. And I do believe that we'll get to a point where we can not only look at what's there, but perhaps even do a functional test to tell you what's the functionality of your soil from a biological perspective. How good is it at disease suppression, nutrient liberation, that type of thing. So I think they're in their infancy, but they're certainly coming a long way.
I was just going to say, can we use them today? But the answer is probably not at this stage.
I think there's some value in them. I think at the moment the big barrier is still cost. Cost can be quite high. But if you think that, when we sequenced the first human genome or the first bacterial genome, it was costing us probably $100,000 or more. We just had 50 genomes sequenced and they cost us $50 each. So you can see what the difference is. The prices are coming down very, very quickly.
There is a test called a microbiometer, which is designed for, I guess, smaller farmers or market gardeners. And what we've discovered, it measures, it gives you a number that sort of represents biological activity. It gives you bacteria versus fungal ratios. But what we found, we found it really useful, but generally it just affirmed what we kind of already knew from observation of the plants that were living in the soil. But reasonably helpful in some ways.
Craig?
Yeah, so I'm not an expert across all the different tests there are, and there are quite a variety of different biological tests, and it is some of them are in their infancy, I guess. But so each sort of different type of test has got strengths and limitations. So I guess there's probably a need to build up awareness of what some of these different tests are, what are their strengths, what are their limitations, but also with the biological stuff, it's a priority to get the physical, chemical stuff sorted first, and then the biological test after that. And it's often on a comparative basis, so it's often not an absolute, here's a value, like pH, you've got an absolute guide to where things are sitting nicely, but a biological test, often it's a comparative thing. You've got to consider similar landforms, similar soils, and then you're looking for a comparison across some samples that you've got a good handle on, I guess.
Yeah, I just add to that and follow up on that. It's really changed through time. It's probably the most useful thing you can do. I've got this number, don't know what that number means specifically. I implement some change in practice, and has that had some sort of impact? I think the other way I think about it is really the way nature solves problems is it throws lots of diversity, lots of biological diversity at it. So we tend to boil all these genomic techniques down to measures of diversity to see how they're impacted.
Oh, we got one. Yes.
Yeah, first of all, thanks very much all of you for your interesting, thought-provoking presentations. So I'm asking this question as a non-farmer. I suppose we as a society are conditioned to getting food from the supermarkets anytime, cheap as possible. How can we start looking at supporting farmers to improve soil health that then improves the quality of the food? Is it something we as consumers can drive, or does it rely on a whole range of other factors?
Yeah, look, it's hard as a consumer, but the single best thing that would help farmers is if people ate more diversely. So we've gone to markets with fruit and veg, and we can sell spuds and carrots and broccoli, but you can't sell kohlrabi or anything. And growers of grain can sell wheat and wheat and wheat and wheat and wheat and wheat and wheat, but they can't sell anything else. Soil needs something grown in between wheat, and so farmers often will grow a different crop in between, but they can't. People won't buy it, so it gets fed to animals. And so whether it's a vegetable, a grain, the more diversity that the farmer can have, it allows them to look up to prioritise soil health. Yeah, so the more diverse stuff you can buy.
So the experience we've had with the wine industry is wine is a luxury, discretionary good that we purchase, and so the consumer actually drives a lot of that people will pay a premium for a carbon neutral, pesticide free, more biodiverse wine that's come from a more biodiverse system. So I think, yeah, there's a really important role for the consumer, but we have to demand that diversity in our systems.
I think it's interesting, it would be interesting getting Matthew's point on this as well, just around talking to that is, I think agriculture does have the challenges with how its production is disconnected from the consumer and how we bridge that education gap, and is it consumer driven, and what role does agriculture respond to the consumer drive versus the agricultural and environmental community saying this is what's best for the landscape, and how we then convey that through the produce we've got on offer. And I think the wine industry is a good example of that, on trying to bring that message through. It's like, it's amazing, you can't get a better description of the poorest quality soil than you can on the back of a wine bottle. And it's an amazing marketing skill that they've been able to capture any constraint they can bottle up into how they can be one of the best wines going around. So it is an art to it, and I think there is need for that more of that messaging within agriculture. And I'd be interested in talking to that, Matt, on how do you bridge that gap on, I guess, that consumer education within the food that you're providing to them? Yeah,
it's a tricky one because there's lots of layers between the farmer and the consumer quite often. So if a consumer can't get access to the grower, or can't grow their own, or you can't talk to the grower, there are lots of things that get in the way. There are, I guess, systems that talk about organics or biodynamics or regenerative agriculture, and I think there's some coming up with biodiversity labelling to say, these farms are doing more in that space, which by definition probably means they're looking after soil health better. But it is that remove. So it's a very hard one to bridge between a farmer in the wheat belt of Western Australia and a consumer at Woolworths in northern Tasmania. There is no connection there. The thing that you can also ask is that your legislators recognise that farmland is a national asset. So we have our farm, but whatever. In geological terms, it's a very small period of time, so all farmland is essentially a national asset. And so it'd be good if there were encouragements for farmers to do better, not just for the ones who've done a bad job and then improve it, but the ones who've been doing a good job for 50 years, because actually there's been lots of them doing a really great job for 50, 100 years, and they actually get less help than the ones who've done a bad job for the last 50, 10, 20 years. So it'd be nice if there was some kind of So, because farmers provide ecosystem services, they provide clean water, like soil is the kidneys of the world really. So they're providing clean water, they're getting rid of feral cats, they're managing bushfire risk, they're getting rid of invasive species, and providing diverse ecosystems. And it'd be nice if that was kind of, there was some kind of recompense for that, because most farmers who do that out of the goodness of their heart, but they also need to make a living because they're a business.
Perfect. Another one on the floor.
I'm really inspired by the urban agriculture sort of stuff, and also the fact that farms are a national asset. But when we have problems with overdevelopment, crowded, like one house getting knocked down, putting up 3 houses, or farmland being used for these really compact housing with no backyards, how can we change that system to allow urban agriculture, allow people to grow their own food and be more sustainable?
Yeah, thank you. Look, that's a question that we often get asked, and I'm not a town planner and I won't pretend to be one, but it does concern me, living in the city in Adelaide, seeing houses knocked down, they put in 2 townhouses, there's a patch of synthetic grass out the front and nothing in the backyard, and it's like, where are you going to grow the food? What we've looked at is the backyards, but there's also a lot of public space. So you've got the roadside verges. I believe the City of Adelaide at the moment is looking at growing fruit trees within the city as well. There's a whole host of really interesting questions that come up around that. But we can look at a whole bunch of land. I think, if we can't make urban agriculture work in a city like Adelaide, where we've got, lots of wealth, we've got lots of land, we've got water, we've got lots of sunlight, then it's going to be a struggle to make it work anyway. So I actually think Adelaide has a bit of an opportunity to lead the way in that space. One thing I've seen some councils do is they'll say, if you put an extension in your house over a certain size, you have to put a rainwater tank in. What if that was a veggie patch instead of a rainwater tank, or leave some bare earth? And then you'd also get the kind of benefits that Craig talks about as well with the human microbiome. So yeah, I think there's really good opportunities there.
It also gets into longer term planning, I think, like the Green Adelaide, Landscape Board Green Adelaide, they're talking about this urban greening strategy, and they're going much bigger than just putting trees, and it'd be good to see productive sort of things going back in the landscape as well. But they're talking about, I guess if cities were better planned and your workplace was closer to walk to or cycle to, there's people talking about road diets, I think, where you could carve up one half of the road and plant stuff in it. So that's not going to happen everywhere, but it needs like really good planning and long-term thinking.
Yeah, just really briefly on that. So if you added up all the urban areas in the world and all the roads, and it would be like the 7th biggest country on earth. It's quite a lot of land that we've built on, and a lot of that's really good agricultural land. By definition, it was flat or near a river. Not the inhospitable stuff is where we built the cities, but that doesn't mean it's lost. So currently, even today, 1 billion people feed themselves from urban gardens, but it's 1 in 8 people around the world. But that's around the tropics, where it's a little bit easier to grow things fast and furiously than it is in southern Tasmania, probably even in Adelaide. But urban land isn't lost until it is paved over completely, or it's, there's a roof that goes from boundary to boundary. And I think where we've lost it is we're allowing good agricultural land to be built on, and then we're also building pretty much boundary to boundary. So where's the shade? So then you need an air conditioner. Where's the food? Then it has to come from further afield. And it is all, it's layers of planning authorities that need to say we're all humans, what would be good for humans into the future, and that would be local food, some shade, exposure to healthy soil for our microbiome, and all those kind of things.
I mean, just to highlight, Adelaide would probably be in many ways an example where you can say all along the Torrens used to be, fruits, vegetables growing. You have a look up through Asselstone, that Ross Trevor area where we had lots of vegetables being grown by the Italian immigrants. Now there's massive developments happening in Virginia, which is more land that's lost. So what we're doing is we're driving farmers further and further out into marginal land, yet we're expecting them to produce the same amount of food at the same cost. And that's just not sustainable. It's ridiculous. If you're going to do that, then open a suburb somewhere in the God knows where and say, this is where you're going to live, because we can't afford to give any more arable, valuable land to concrete. It's that simple.
Yeah, just one more quick point on that as well. There's research that shows that people who grow their own food are less likely to waste food. And so even if you're not entirely self-sufficient producing all your own food, even if it's, you know, one little dodgy tomato bush on your balcony in a 20-storey building in the middle of the city, hopefully that gives you a better appreciation of the food and what it took to produce the food that you buy at the supermarket. So I think any sort of engagement in your own production also has those flow-on benefits as well.
Excellent. Another one from the floor at the back.
Hi. This is just, it's not really a question, it's just getting your thoughts on something. So the general sense of it, we can't create something new from the same problems we started it in. And so I'm just wondering what you thought if we had soil scientists and microbiome specialists, nutritionists and farmers in a new public health model.
Yeah, I mean, I call myself a soil ecologist because I'm interested in soil and the living component of the soil, but I actively collaborate with people in different disciplines, in economics, in social science, in engineering. There are some in health as well, one in public health, and Craig can obviously speak to this as well. But yeah, it's a multidisciplinary problem and none of us have the solution alone. We've got to work together to solve that.
Yeah, I guess the environmental microbiome influence in public health and it's probably a little bit fringy still, but it's gaining more recognition. The diet and nutrition is probably way up there, far higher in terms of public health. But yeah, there is a lot of public health is probably the poor cousin as well of health in general. So yeah, it's a good move, probably to move to something that's a bit more integrated and holistic.
Oh, we had another question down here, Jeff. Sorry.
Thank you. A comment to the question from back here. There is the Savory Institute in the United States has been working with the Michigan State University and someone from South America, the name I can't remember, to develop an ecological outcome verification process rather than a certification process, which is about what processes are. This is verifying the ecological outcomes on a particular patch of soil or a particular farm. It's still being developed. It's well underway here in Australia as well. And part of that is going to be taken to, it's a means to take ecological results of the growing of food and fibre to the market, to the public. My question is a lot more small scale. We've tried to grow lots of our own food at home and we have no dig processes and so on. The one that I really struggle with is how we keep the soil going, how we keep the biology alive when we're growing alliums, which need to be, as far as I've experienced, need to be in monocultures, even if it's just a small patch, and they've got to dry off for several months at the driest, hottest time of the year, and the soil at the end of it looks bloody awful, even when it's covered with compost and so on. I'm just wondering if anyone's got any insights into a way to improve that. Very specific question.
Yeah, I think about you want to maximise the diversity in your system, and you can do that both in space and time. So that can be, here's a patch of ground and I've got 10 different things growing at once, or having that rotation through that. So perhaps part of the solution is you have the alliums, but you don't put alliums there again for a period of time, and you rotate it through that way.
I mean, there are places where, there's a place in Italy where they've grown onions in the same field for the last 300 years, right? And you sort of look at that and you go, how the hell are they doing it? But I dare say there's some sort of voodoo we don't know about. No, but it probably is just a case of maybe they're growing different varieties of onions to give some variability. Alternatively, they've got, I mean, I guess from our own experiences, what we found is there's something called sick soil disease or replant disease, which is really common for people that grow roses or apples and these sorts of things. So anything from the rose family. And what we found was that if you actually take stock and go back a step and put in, say, a mustard crop in between, I mean, in this case, mustard crop's also going to take a lot of sulphur out, but you put a mustard crop in between and put organics in, and then often what we find is that sick soil and that replant disease is actually much suppressed. So in the Adelaide Botanic Gardens, they used to literally dig out the soil and put new soil in for their rose gardens. They don't do that anymore. They basically do this system where they rotate a green mustard crop through, put organics in, and then replant. So maybe that's one option.
Sorry, there's another one over here.
I think my question is to Craig. You were talking about the benefits of... No, it's not the one I forewarned you of. It'll come later. You were talking about the benefits of growing plants in soil and the benefits to the consumer. What's your view on hydroponics?
Yeah. I've got to say, I tried growing vegetables and it is very hard, and so I'm probably not anyone to advise on growing food to eat. I guess hydroponics, you're not getting the natural soil ecosystem there unless you're adding stuff in there, really. It's kind of all water and nutrients, isn't it? So you're not really getting any microbial aspect that I'm aware of.
Yeah, I think hydroponics is a really good example of the hubris of humanity, thinking that we can outsmart nature. So you can grow hydroponically, but if you're interested in flavour and potentially nutrient density, are you getting the most from that? From my experience, no. And it would be a miracle if, so what's happening around the roots of those plants, and all these guys have been talking about it, the chemistry, the physics, that amazingly complex interaction that the plant has evolved in. So plants and soil have co-evolved for 500 million years, whatever it is. It would be a miracle if a human just happened to guess what plants need so they can put it into the water that goes beneath the roots. So yes, we know what the macronutrients of plants are. It's the same way we know fats, carbohydrates and proteins are macronutrients for humans, but we still don't really understand the micronutrients for humans. And so it would be a very lucky and happy accident that we would know the chemicals and the things to put into the water that the hydroponic plant is grown in to be as nutrient dense and amazing and delicious as a thing can be in the stuff that was evolved to grow in.
I recently spoke to one of the biggest tomato growers in Australia who grow all their tomatoes hydroponically, and we spoke about enhancing flavours by the addition of certain microbes to their growing medium. And begrudgingly he told me, as he was very embarrassed by this, but he basically said people don't buy on flavour, people buy on colour. That was his take on it. I'm sorry to say, but that's how the supermarkets work. I mean, I can give you another example. At New Chog we have the rare fruit arboretum. We have several hundred different varieties of apples, pears, whatever you can possibly imagine. You'll find none of those in the supermarket because people don't want them because they don't grow in the same way, they don't store in the same way, and so we're really limited about what we have access to, which goes back to this whole idea of let's eat more diverse. Well, it'd be nice if we could get it, but hydroponics isn't helping us in that respect.
Another question down here.
That's a really good question. I think unless we go to more regulations, I'm not necessarily a hugest fan of regulation because it puts a lot of impost on smaller growers to meet certain guidelines. I think supermarkets just sell you whatever they can grow in bulk and whatever stores the best, and it's that simple. If I've eaten fruit from supermarket and if it didn't have a label on it, I wouldn't have known what it was because it just doesn't have any flavour. I mean, I can tell you about strawberries I've eaten recently, and I think unless somebody told me it was a strawberry, it could have been cardboard soaked in water. So I think there is an issue with the way we currently mass produce food with virtually no flavour. Yeah.
We didn't really get into this, and it's probably a big chunk missing out of the lineup today, but certain micronutrients or elements missing out of food can impact your health in the growth, the way your bones form and shape and various things. So if you're missing some of these small sort of things in your food, that can really impact on your health. So yeah, just the colour of it and how well it, withstands, being knocked around is not really going to feed our health in the long term.
Yeah, so we're successfully growing the least nutrient-dense food in human history because farmers get paid per kilo, not on nutrient density. So what you're talking about is something that people can put onto a vegetable just to compare one carrot to another to say what is more nutrient-dense. And if that becomes available to the average person, it will change the game completely because lots of farmers who are interested in soil health and are interested in nutrient density, and so they're choosing varieties and choosing how to manage their land in a way that they believe provides nutrient density, can be rewarded for that because the current system is just bigger, better. We know what's called the dilution effect, where plants have more carbohydrate but less micronutrients, less protein potentially, but less certainly micronutrients. We know that's been well established over the last 50 to 80 years. That we eat, in Finland they eat more vegetables than they did in the 50s, but gets less micronutrients, which is a really nice example. And so this would be a game changer, having something the average person could have in the greengrocer to compare, one carrot to another, one lettuce to another, one cabbage to another.
I've been growing some vegetables in raised beds, and some of them are sulking, and it seems to me from listening today that they're missing some of the good stuff, the fungal and the bacteria and so on that's not in the Jeffrey's organic soil or whatever that I get from the landscaping shop. So I'm wondering, are there any are there things you can do for those sort of urban gardeners and raised bed people that can sort of juice up the soil quality in that environment?
Look, the secret ingredient to home gardening, and it's hard to do on scale, but the three things, my wife's, she ran our market garden for a few years, she's a better gardener than me, so she said, and you've got to remember them in this order, is compost, and compost. But it could be potentially there are some things like iron or manganese or something that is leached through your soil, like your actual rock minerals. So you can buy a thing called rock dust, and it's very young rock that's recently bubbled up from more recently than 500 million years ago, 4 million years ago, a crushed up rock, and that has a lot of those trace elements in. You only need a handful per 2 square metres, and you can buy that in garden centres. Might be worth throwing some. It doesn't hurt to add a bit of that, along with some compost.
Having that same experience myself in my garden, I guess what I found was that the soil was really good for a few years, and then it became extremely hydrophobic. I mean, my soil, I've managed to improve it now, but it's taken a long time, and it's often these sandy loams that you buy in for raised garden beds become extremely hydrophobic. So what hydrophobicity really comes about by soil particles being coated with an oily or waxy substance. So when you're taking something like a sandy loam, which obviously you probably have, you need about 3% of those soil particles to be coated with a waxy coat, and the entire soil becomes hydrophobic. For clay, you need about 10% of the soil particles. So what happens over time is that the organic matter that was in your sandy loam to start with has broken down. The really recalcitrant organic matter is often quite waxy. It's hard to break down. And so what happens is it coats these soil particles, you water, and it may disappear, but it's probably likely just going to run out the bottom of your wicking or out of your beds again. So often it's a case of, yes, putting organic matter back in, whether that's composts or a good organic fertiliser. Sometimes a little bit of nitrogen can help to break down that waxiness if that's what you think might be happening. But yes, I've experienced the same thing in my own garden. Yep.
Yeah, I'd just say also, whenever you remove produce, you're taking away nutrients that have been extracted from the soil, so you do need some sort of replenishment over time. And I think what Yui said makes a lot of sense.
I'm going to go back to, I think, Ed, you sort of started this session with asking us to think about whether we go back to basics or, go sort of high tech or whatever. I guess I'd sort of say don't be scared of getting a soil test, just to sort of see if there's any key macro or micronutrients that are missing. And then, then there's the first principles, compost, etc. So a bit of a combination of take advantage of some of the quite efficient tests that are available, just basic physical, chemical stuff, and then go with first principles, I think.
Yeah, and I think adding to that is, again, water is usually the key thing, and it's how we're accessing that water. And hydrophobicity was touched on, but also what does water do to salts? When we see some of these organic base systems, we can find in a lot of garden scenarios might be compost. That's the thing. It's a processed product. There has been a properly composted method to composting. What you can find if you have been using some of the raw manures, or less composted materials, you can actually find this salt accumulation building up, and depending on the structure of beds that get made up, drainage is usually still a big thing in raised beds. And what you can find if they're not draining well, you actually get an accumulation of salts at the bottom, and then over time it just keeps creeping up, and your efficiency of that water you're applying, the soil might look wet, but the plants aren't able to extract that moisture out of it. So if it's a general lacklusterness on plants, usually water is the driver. If it's showing yellowing of leaves, depending if they're top or the bottom, that's then going to drive more of a nutrient deficiency.
Thank you. So generally as gardeners maybe, it's often recommended that we rotate our vegetables or whatever to reduce the chance of pests and diseases. But by the sound of Matthew's carrots and the voodoo onions, sounds like maybe a hands-off approach and soil diversity could actually be our biggest tool moving forward in the health of our vegetables or plants?
We certainly rotate the crops. So we have 70 garden beds, so we don't grow carrots directly after carrots. We rotate through, so we'll grow a brassica, then a nitrogen fixer like peas or beans or something, and then maybe a green manure crop, and then carrots again, or alliums, and then, So we go through, we do rotate. So diversity over time. If you can't do diversity in the space at the time, diversity over time is really important for disease pressure, for soil, because every plant gives something to soil, every plant takes something from soil, so that just makes it a better ecosystem below ground by having a different ecosystem above ground over time.
If you look at a natural system, you tend to find if you've got a more diverse plant community, you've got more diverse inputs going into the soil, and that drives a more diverse microbial community in the soil. So the above ground diversity is a really good driver of the below ground diversity, and vice versa as well. It's kind of chickens and eggs, which one came first. The other thing, I guess, we talk about microbes, and we're sort of putting a very beneficial bent on things here about the great things that microbes do, but there are also some that are pathogenic and cause disease as well. So that's why you rotate those crops, because if you follow potatoes with potatoes, you're going to get potato-cyst nematodes and so on. So you need to really have that rotation as a way of managing the pests, but also building up the diversity of the beneficials.
Yep, down the back.
Commercial potato growers will actually only plant every 5 years to the same patch. In between, they'll plant barley or something else.
Down the back.
Yeah, thanks. Just shifting big picture. Matthew, one of your slides said Australia's on track to abandon 100 million hectares of land the next 500 years. I know 500 years sounds a long time, but geologically, it's a blink of an eye, and it's a lot of land. So what are the key drivers behind that? And more importantly, how can we change it around both now and into the future?
Yeah, the key drivers, one is climate change, so it's getting hotter and drier and more difficult to... So what are the limiting factors for plant growth? And it's, water, air, sunlight, whatever. But certain plants can't grow where it's getting really too hot or it's too dry. And the second is loss of carbon in soil. So in Western Australia, wheat belt, a lot of those areas maybe only been used since the 50s or 40s. They've lost half their carbon, in 40 years, 50 years, and they know they're going to lose the next half in the next 20, 30 years, but they can do it because they can add artificial nitrogen. They can, they do what's called a summer fallow, where they spray everything with Roundup, which means that they cut the food source off. There's no photosynthesis, so there's no carbon being sucked out of the air and fed to the underground ecosystem. But they can do it, and they're still, they're all buying new cars this year, new tractors this year, because they can make lots of money out of it, especially with Ukraine. And so, what are the drivers? The fact that farmers can make money and ruin soil at the one time, and that farmers are a business, and so some will care about soil health and some won't, and climate change. So, but you've got to remember, like something like 15. So I probably should have done this in my thing, but there's actually something like 15% of Australian farmers say they are approaching their land in a regenerative way. So they are actively trying to work out how to grow topsoil and restore ecosystems. And that doesn't sound like a lot, 15%, but that's actually a massive increase on what it was 5-10 years ago. And so there are lots of people doing really cool things. And the farmers who are ruining it don't necessarily think of themselves ruining it. They just think, well, I'm making money, so I can't be doing anything wrong. And there is a bit of a blind spot sometimes to the science, because science, my dad was a scientist. I've got a degree in biology. God loves scientists, a bit boring sometimes, and farmers don't want to listen to them. And or they can't, or the message isn't been put in a term that a farmer can understand. So it's not bad people. It's just that some of the things that we have done historically have damaged land. But there are people doing amazing things, and particularly in Australia and other marginal places like Africa and some of the dry parts of America, in terms of, and even through China and places like that, doing amazing things in restoring soil as a living, breathing superorganism, treating it like a living, breathing superorganism, and how to nourish it, because all we have to do to eat, to farm, to grow food for humans is we eat plants and animals, and that they've been on Earth for hundreds of millions of years, and all we need to do is insert ourselves between when that plant or animal was born into this world and before it's completely rotten. So that's all we need to do. It's a very simple thing. So we know we can farm forever. We know we can grow food forever, because all we have to do is eat the things that grow on Earth. But we have to work out how we don't bugger up the earth that is growing those things for us. And there are really clever minds who we actually know how to do it, but we have to roll it out at scale in a relatively short period of time, because we've now realised, Mars doesn't look that hospitable.
Oh, Will, because it continues on. You haven't touched much on the role of animals and manures in good soil health. So I'm just wondering if you could talk about that.
So soil co-evolved with plants and then with animals. So animals have been around for a long time. So if you take animals out of the system, so a really good example is, so soil fertility moves downhill all the time, so valleys are always more fertile than the mountaintops, but animals are really good at moving fertility around. Humans have managed to get rid of animals out of landscapes, so we got rid of lots of birds, lots of big herds, lots of big animals, the megafauna, and that has changed the way nutrients are moved. So when a cow is a good example of a modern animal, when a cow walks up a hill and does a turd, moves a lot of fertility uphill really fast. That never happens without an animal. Even better, not for the cow, even better is if the cow dies at the top of the hill, and all that massive fertility then is moved around. So we need animals in a healthy soil ecosystem. Those animals could be insects, but we seem to be annihilating. I think we've lost half the insects on Earth in the last 50 years, and in our cropping lands we annihilate them all. And we need animals to cycle nutrients, to spread nutrients higher up. We need, they're a really important part of the ecosystem. So for me, soil health needs to include animals. They can be wild. You don't have to eat them if you don't want, but sometimes it'd be clever to use them to feed humans. But they're an important part of the soil ecosystem.
I guess when you're looking at animal manures as a form of nutrient for plants, then you can look at it several different ways. So if you're taking things from chickens or ducks or turkeys, because they excrete the urea in the same effect as they excrete the solids, those manures from those type of animals tend to have a higher nitrogen. And if you take, say, a factory chicken, because they're fed so intensively, their manure is actually quite high in pretty much every single trace element a plant could want. You compare that to a cow. A cow's manure may be as low as 0.5% of nitrogen. If you get cow manure from a feedlot, it'll have nitrogen around the 2 to 3% mark, because they're intensively fed with grain. They just excrete the remainder. But animal manures are a great source of nutrients, and they're virtually free. They need to be composted for sure. But when you compare that to the amount of energy that's required to make a kilo of ammonia or urea, animal manures come out way on top ecologically every single time.
But this is apropos of a number of questions and some of the responses. You might not realise it, Matthew, but in South Australia we have a dry season which sort of extends from about end of October This year is a bit different. And I'm just wondering, are we doing the right thing by our soil by irrigating over summer? Now, on the broad acre, of course, we're growing annual crops, and that suits this environment. But a lot of what we're growing in the other areas, particularly along the river, but elsewhere as well, requires us to put on water every year, which is quite unnatural for that soil. Am I worrying about something unnecessarily?
Yes and no. Anyone who's got a garden at home knows, all your annual vegetables die if you don't water them, pretty much, if you live in a climate like yours and ours, which is dry over summer. So what are we trying to do? We're trying to feed people. When you're growing food, whether it's at home or whether it's a farm or a market garden or whatever, you're trying to. What are you trying to do? You're trying to grow food for yourself or fibre or whatever for the world. And so what do we want? We want food and fibre from our farming land. So how do we get it? Well, the best way is to nourish the ecosystem that nourishes us. And there are irrigation systems that have been terrible for land, and there are irrigation systems that have been fine, that you can do for a long time. It probably depends on where it is, how saline, how much you change the water table, what crop you're trying to grow, where's the water come from, how much you're putting back in the river. So there's no easy answer. But what we need to do is say, I always think, or step back and go, okay, so what do we want to do? We want to grow food, here, wherever, for 1,000, 10,000, 100,000 years. So what is changing over time? Is it getting better? Is it getting worse? Or is it staying the same? If it's staying the same, you can do it for 100,000 years. If it's getting worse, you've got to change it again. And if it's getting better, thumbs up. But every place, every farming system, everywhere is slightly different.
I think we can take an example from California, where they're effectively now removing a lot of their plants again because they just don't have the water. So a lot of their almonds and stuff are being pulled out. An almond orchard will take 12 megalitres per hectare. 12 megalitres. A large swimming pool is 100,000 litres. So that shows you how much water we need. Now, at the moment, the Murray is obviously, flowing at 180 gigalitres a day. So, everyone thinks great times are ahead. But, we do need to think about what we're growing where and when. And, so maybe there's certain crops we shouldn't be growing and we shouldn't be watering them. The Californians basically don't have the water to grow them. So they're probably in Australia. Yeah. Well, that's why I said, that's why we need 12 megalitres a hectare.
I'll just add, like a measure of soil health has to be fit for purpose, and it's going to vary with different land uses, I guess. So then there's not one size fits all in terms of measuring soil health. It's going to vary with your land use. So then you can track if it's going up or down. And there's obviously those bigger picture issues.
Yeah, I think part of that is making sure the moisture content is, or the added moisture content is matching what your sort of intensity go back to on what you're trying to do. At the end of the day, that each megalitre is another 100 millimetres of water. So you've got areas that were 300 mil rainfall areas that are now 1.2 metre rainfall areas, but with that 12 meg. So it's just putting it in perspective and saying, right, what's happening with that nutrition, what's happening with the water table in relation to that, what are we actually doing to fulfil that, and then work back from there. And part of it is just putting it into context around what you're trying to achieve. But if there's purpose for it, and there's a fit, and you've got balance within that system, then you're managing that system with the added water, where otherwise it would have been dry. So it's just managing that dry cover for that year. You can manage that higher moisture for that longer period of time, but you've just got to make sure your inputs and cycling is going to be able to keep up with that added moisture content. We're closing in on time, and I know we were trying to just touch on a little bit of looking to the future, and the future is driven by investment as well, and I know there's been a lot of investment into the likes of some of these biological processes, measuring novel processes around looking for new biology and culturing it up. There's been significant investment in endophytes, so looking at building more carbon, extended root systems on soils, but also, Yui touched on it with the free-living nitrogen producing bacteria. There's different companies getting going to replace the synthetic nitrogen. Nitrogen is obviously a key component of building protein and stepping that on. I guess as we look towards that high-tech future, or potentially high-tech, is it high input or low input, high touch, low touch, what would be something that you would really love to be able to introduce into your system or think would be of high value to the agricultural system if we could bring it in today rather than in 20 years' time, maybe?
I'll start with that one. So the way I look at it, we've narrowed our farming systems, right? We used to work with quite diverse systems, and we've got synthetic inputs and a lot of large mechanization and all those kinds of things that have kind of narrowed our ecological niche that we're operating within. And I think what we need to do is broaden that niche. The way that we do that is we head back in the other direction and bring in some of those natural ecosystem services and processes. The problem or the challenge with that is because they're so incredibly complex, they become difficult to make predictions about them, about how they're going to behave. And farmers want certainty that if I do X, Y is the response. That's why it's so easy to sell synthetic fertilizer, because you add it, the plants got bigger, right? So you're introducing more complexity. So I guess the big thing that interests me anyway is trying to understand that complexity so you can make reliable predictions about it, because then you can scale it out on a much larger scale.
I'm going to go with soil testing, because that can be a win-win, and I'm not being paid by any soil testing labs. It can be a win-win because if you can kind of optimise, obviously if you're removing plants and animals, removing product, and your soils you can't mineralise nutrients out of your soil. There's going to be often a need to replace those nutrients in the soil. But if the farmer's spending more money than they need to and putting more nutrient on than they need to, it's either leached and going to cause problems in groundwater or surface water. It's impeding the mycorrhizal fungi from doing their thing. So there's a win there if the farmer has a better idea that they can maybe hold back a bit on their fertiliser. There's a win for the environment and there's a win for the farmer's pocket with their wallet. So I'd say if the federal government could promote more soil testing, throw a bit of money at that, I think it'd be a win.
So Medicare for soil? Yeah.
I guess there's a couple of ways I like to look at it. I like to look at what are the big players in the market doing? What are the BASFs, the Bayers, the China Chems doing? And they've had the playing field for themselves for a long time in regards to chemicals, whether it's herbicides, pesticides, fungicides, whatever sides you can possibly think of, including all the various fertilisers. And I think that really they're moving now towards biology. They're spending huge amounts of money getting into the biologicals, and I think that's where the future lies. What we need is, exactly as was said down here, we need to make maximum use of our fertiliser. And I stress this to growers all the time. I talk about something called fertiliser use efficiency. And there's no point in putting more and more stuff on if all it's doing is getting locked up or being washed away. So, we need to look at how do we put fertilisers on that release nutrients over time? How do they get released so that the plant is used to it? And I think the way I often look at it is that biology, and I look at it from a microbiological perspective, the rate at which microbes release and break down organic material is matched often with the plant's growth. As it gets warmer, the microbes work faster, the plants grow faster. It's a beautifully matched system. So I still think the future, the future is really in improving soil biology, and part of that is to make sure that we get the maximum use out of the fertilisers we can.
Yeah, that's a hard question, but I'm going to say slightly different slant. And what I would hope in the next 20 years is that certainly the people growing food and those charged with, I guess, legislating or looking after those growing food maybe reframe how they think of soil and think of it as a living, breathing superorganism, a self-perpetuating ecosystem that has its own complexity and nuances that we may never fully understand, but that we can understand enough to manipulate in a way that we can grow food. So when I say living, breathing superorganism, so I don't think of soil as 10 billion living things in a teaspoon of healthy soil. I think of it like my cow. So my cow, would I cut her open for no reason? Right? No. Why would I do that? Why would I dig soil for no reason? It's bad for it, right? Would I shave all the hair off my cow? Would I, no. Why would I do that? It's no point, unless I have a reason. Unless I've got a good reason. So why would you get rid of all the plants off your soil? Would I inject her with something? Would I add chemicals to her? Would I add poisons to her? Well, yes, if she's got some kind of lice infestation or something I can't deal with, or she's sick, but would I do it for no reason? Never, ever, ever. And so when you think of the thing that nourishes us as a singular organism that is self-organising, it maybe changes the way we view that thing and how we treat that thing. And yes, we'll still be involved in managing it. Humans have managed landscapes forever, and we're going to get involved in soil. We might, have to dig it. We might have to add things to it. We might have to change it. But that doesn't mean. But if we frame it as okay, so is that for the long-term good of the soil, as opposed to will that give me money in the bank for the next 3 years?
Brilliant. No, thank you all for those insights, and conscious of time, and thank you all for coming here today. But I'd love to have a big round of applause and thank you for Matthew, Yui, Tim and Craig for the coaches up on stage. Thank you. Again today, a huge thank you to the Hills and Fleurieu Landscape Board, the Australian Government's National Land Care Program, the SA Drought Hub, Soil Science Australia SA branch and the Mount Barker Council. Thank you so much for all the support to making this event happen. I'd love a big round of applause for them. Thank you.